Try it again. That's what we'll try it again. That's what we're going to do right now. We're going to try this again. Only we're going to try it a couple different ways, if you don't mind. I think the first and obvious way is the algorithm. So let's try that real quick. We have our keep, change, flip, which means we're going to keep this the same. We're going to change the sign to multiplication, and then we're going to flip. So we'll put the 4 up top, and we'll put the 1 on the bottom. And now we can simply multiply across the top. 3 times 4 is 12, and multiply it across the bottom. 1 times 1 is 1. Now remember, a fraction is a division problem, and 12 divided by 1 is still 12. So that's going to be my quotient. Now, just to prove that 12 is in fact the quotient, we should try and draw some pictures. That's right, today we're going to be doing the algorithm and drawing pictures. So let's do that real quick. How can we illustrate that the answer here is in fact 12? Well, I always like to start by drawing a picture of the dividend. The dividend, it gets divided in the end, the dividend. I said the dividend. That's the fraction on the left. So this represents 3 wholes. So how about we do 3 whole candy bars? That's 1 candy bar. That's 2 candy bars. And this is 3 candy bars. And thus we have represented the fraction on the left. Now, what we're really asking here is how many times 1/4 will go into 3 wholes? So why don't we just cut each of these candy bars up into 4 pieces? And then count how many times those 1/4 pieces will go into the 3 full wholes. So as you can see, I have now cut each of the candy bars up into 3 pieces. I want to see how many 1/4 will go into that. I think we can all agree this is 1/4. That's 1/4. That's a 4th. They're all 4ths. So let's just count it up. So we got 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12. And thus we have illustrated that the answer is in fact 12. Now, I know what you're saying. You're like, can you give me another example? Well, the good news is I can and I will and I'm gonna right about now. What if we had 3/4 divided into 3? Let's do that. So what if we have, okay, so 3 is going to be our whole number. So we have 3 over 1. And we divide that by 3/4. How can we find the answer to this problem? Well, first you can use the algorithm. So we're going to keep this the same. We're going to change the sign to multiplication. Then we're going to flip. We're going to put our 4 up top, and we're going to put our 3 on the bottom. And then we can now multiply across the top. 3 times 4 is 12, and 1 times 3 is 3. Now remember, this is a division problem reading top to bottom. 12 divided by 3 is in fact 4. So the answer is going to be 4. So I'm going to put that down here just so we remember. But how do we draw a picture of this? Well, you know what I want to use? I want to use some candy bars. So let's illustrate this fraction on the left with candy bars. So we have 3 whole candy bars. There's 1, there's 2, and here's 3. 3 whole candy bars. Now, because we're trying to find out how many times 3/4 will go up into 3 wholes, it would be helpful to cut these up into 4ths again, since we're dealing with 4ths again. So we're cutting these each up into 4 pieces. And now we're just going to count groups of 3 because it's 3 times as big as 1/4. It's 3/4 this time. So that's 1/4, 2/4, 3/4, right? And let's use a different color over here. 1/4, 2/4, 3/4. 1/4, 2/4, 3/4. 1/4, 2/4, and 3/4. So how many groups is that? Well, here's 1 group of 3/4. Here's 2 groups of 3/4. Here's 3 groups of 3/4. And then our 4th and final group of 3/4, which is nice because that was our answer. There's 4 groups. 3/4 will go into 3 wholes 4 times. All right, so let's try another example just because we can, and we want to drive the point home just a little bit. What if we were to deal with something like 3 halves? Let's do 3 halves. So we have an improper fraction, 3/2, and we're going to divide that by 1/4. So, once again, we can use the algorithm. Let's do that to begin with. So we're going to keep change flip. So we're keeping this the same, 3/2. We're going to change the sign to multiplication, and we're going to flip. We're going to put our 4 up top, and we're going to put our 1 on the bottom. Now, we can multiply across the top. 3 times 4 is 12, and then 2 times 1 is 2. And remember, fractions are division problems. Reading top to bottom, 12 divided by 2 is in fact going to be 6. So our quotient is 6. The answer should be 6. But can we prove that with pictures? Well, let's go ahead and see if we can draw a picture. Remember, we're drawing a picture of our fraction to the left, the 3/2. And I'm going to use candy bars again, only this time this is going to be worth 1/2 of a candy bar. This is going to be worth 1/2 of a candy bar. And this is another half. So maybe I'll label it in different colors. So this, from here to here, is just a half a candy bar. From here to here is another half of a candy bar. And from here to here is another half of a candy bar. So we have 1/2, 2/2, 3/2. 3/2 we've represented. Now, we want to find out how many times 1/4 will go into 3/2. Well, I know that a half of a half is a fourth, so I can actually technically cut these each in half, and each piece is going to be equivalent to 1/4 of a whole, right? So now it's just a matter of counting up how many times 1/4 will go into this. So count with me. 1, 2, 3, 4, 5, 6, which was our answer here. So 1/4 will go into 3/2 6 times. Let's try another one, children. So what if I were to encounter a problem that looks more like this? What if I were to have four holes, and I were to try to divide that by 1/6? Well, let's do the algorithm first. So I'm going to go ahead and do my keep, change, flip. So I'm going to keep this the same. I'm going to change the sign to multiplication, and I'm going to flip. I'm going to put my 6 up top, and I'm going to put my 1 on the bottom. Now I can multiply across the top. 4 times 6 is 24. Multiply across the bottom. 1 times 1 is 1. And as always, fractions are division problems. 24 divided by 1 is simply 24. So our quotient is 24. I'm going to put my quotient down here so I remember what it is and see if I can illustrate this with pictures. Okay, so let's dive right into it. 4 can be represented by 4 candy bars, 4 whole candy bars. So here's the first one. There's the second one. Here's the third one. And the fourth and final candy bar. Okay, now, as always, I want to see how much this guy goes into that. Okay, how many times will 1/6 go into 4 holes? Well, because I'm dealing with sixths, I need to split these all up into 6 pieces individually. So let's start with the first candy bar. I know that if I cut it in half, and then I cut each of the halves into thirds, I'll have 6 total pieces. See, 1, 2, 3, 4, 5, 6. So I have 6. I just need to do that over here. Cut it in half, then cut each of the halves into thirds, and I'll have 6 pieces in each of these lovely, lovely candy bars. Okay, so now, assuming that I've done this correctly, they should all have 6 pieces each, which makes it very easy to count up how many 1/6 will fit into 4 holes. So let's count it up. 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13, 14, 15, 16, 17, 18, 19, 20, 21, 22, 23, and 24, which was our quotient before, and thus we've illustrated that's why it's 24. Now, what if we were to tweak this problem just a little bit more? Let me go to another slide, and let's try a different variation of this. Like, what if we were to Let's use the 4 still. So we have 4 whole candy bars, just for illustrative purposes. And we're dividing it by a number that is twice as big. This is now 2/6, right? What do you think that's going to do to the quotient? Is it going to make it a larger number, a smaller number, no change at all? What do you think? Well, let's find out using the algorithm, then we'll draw a picture of it. So we're going to do our keep, change, and flip. We'll put our 6 up top, and we'll put our 2 on the bottom. And now we can multiply across the top. 4 times 6 is 24, and 1 times 2 is 2. Now, remember, fractions are division problems. Reading it top to bottom, 24 divided by 2. 24 divided by 2 is, in fact, 12. So, it looks like our quotient is 12. We're going to put that down here so that we remember it. And let's see if we can draw a picture that illustrates why it's 12. Like, why did it go down so much? Well, you tell me. Maybe it's because the divisor is twice as big. Never know. Anyways, let's see if we can draw a picture of this. So we're going to illustrate the dividend, or the fraction on the left, by drawing 4 full candy bars. So we have 1 candy bar, 2 candy bars, 3 candy bars, and 4 candy bars. Okay, sorry. I'm having a moment over here. And because we're dealing with 6s again, only it's 2/6, we got to cut each of these up into 6 pieces, right? Right. Okay, so let's go ahead and do that. We're going to do it the same way we did it last time. We're simply going to cut the candy bar in half, and then cut each of the halves into thirds, and that will add up to 6 total pieces. We're going to do that over here as well. 6 pieces in that candy bar. Over here as well. And I promise I'm trying to make them as even as possible, but I also don't want to bore you by pulling out a ruler and making it perfect. So bear with me. Okay, so each of those should be cut up into 6 pieces. Only instead of one of the 6 pieces, it's actually going to be 2, right? We're looking for how many times 2 6 will go into 4 holes. So this is 1/6, and that's 2 6. Okay, that's one group. Let's use a different color. 1 6, 2 6. 1 6, 2 6. See what I'm doing here? Different colors. 1 6, 2 6. Okay. 1 6 here. Another 6 there makes it 2 6. 1 6 here. Another 6 there makes it 2 6. And you just kind of keep going with the pattern. 1 2. There's a group. 1 2. Another group. 1 2. Another group. 1 2. Another group. Okay. We're grouping up pairs of 6s. So 2 6 each. All right. Now, how many times did 2 6 go into 4 holes? Well, it went once, twice, 3 times, 4 times, 5 times, 6 times, 7 times, 8 times, 9 times, 10 times, 11 times, and 12 times, which is nice because that's what we came up with our algorithm. Okay, let's do one more example. Let's change it up even more. We're keeping similar numbers, only we're going to make it a little bit more different. All right, don't quote me on that. All right, so what if we keep the dividend the same? So we have 4 over 1, so 4, and we're going to divide it by an even larger number. This time, instead of 1 6, 2 6, we're going to do 4 6. Boom, it's even bigger. Is that going to make the quotient go up or go down? And if so, by how much? What direction? What do you think? Well, let's go ahead and do the algorithm. So we know we got to keep, change, flip. So we're going to keep this the same, 4 over 1. We're going to change the sign to multiplication. And we're going to flip. So we're going to put our 6 up top, and we're going to put our 4 on the bottom. Now, we can multiply across the top. On the bottom, so we got 4 times 6 is 24. And 1 times 4 is 4. Now, remember, fractions are division problems. Reading it top to bottom, we have 24 divided by 4, which, of course, is going to be 6. So our quotient is 6. I'm going to put my quotient down in the bottom left corner so we remember it. And now let's see if we can draw a picture illustrating this fact. Okay, As always, I'm going to begin with a fraction on the left, which is 4 over 1. Draw 4 candy bars to represent 4 holes. So there's 1 candy bar, 2 candy bars, 3 candy bars. Everybody, 4 candy bars. Okay, now, how many pieces do I have to split each of these candy bars into? Well, you guessed it, my friends. We're dealing with 6s again, so I got to split it into 6 pieces each. So let me do that real quick. I'm going to cut that in half. Cut each half into thirds, and theoretically, I should get myself 6 pieces. 6 pieces. All right, so I did it right there and right here. Boom, we're dealing with 6ths. Okay, now, it's not 1/6, it's not 2/6, it's 4/6. I got to find out how many groups of 4 I can get out of 4 holes. So again, we'll use different colors. 1, 2, 3, 4. That's one group. And let's do it again. 1, 2, 3, 4. That's 2 groups. 1, 2, 3, 4. 3 groups. 1, 2, 3, 4. 4 groups. 1, 2, 3, 4. 5 groups, and then our final group is going to be 1, 2, 3, 4. So 6 groups. See? Looks like we proved it. There's one group, that's 4, 6. There's another group, that's 4, 6. Another group, another 4, 6. Another one, and another one. Anyways, you guys can see that there are, in fact, 6 groups of 4, 6 that can fit into 4 holes. Anyways, I do hope this tutorial was helpful to you. If it was, yay. I hope you have a wonderful day doing whatever you're doing, and that these fractions are now visualized for you. Have a good one. Bye.